Good evening, everyone. Hello, everyone. This is an open day for the DLT for All project. This open day is co-organized by University of Nicosia, SEERC, and Gnomon Informatics. DLT for All project is a project funded by the Erasmus Plus program of the European Union. And its goal is to make blockchain and distributed ledger technologies and their application understandable. Short introduction in our agenda. We're going to make a short presentation by Dimitrios Spounis, which is a software engineer. And later we're going to have a roundtable discussion with our panelists, Dr. Haris Savidis, advocate and law lecturer in the University of Nicosia, Adrian Thras, managing partner of Anthology Ventures, and Dimitrios Spounis, software engineer and expert on blockchain and smart contract technologies. Also, we have to mention that for dissemination purposes, this session, this open day, is being recorded and will be uploaded in the DLT for All YouTube channel on later days, so as to for more people to be able to watch it. We are going to start now with Mr. Spounis. Would you like to start your presentation?
Sure. Thank you very much, Corina, for introducing me. I'm going to begin this open day with a short lesson and presentation on blockchains and smart contracts. I will try to not bore you too much. As I'm beginning my screen share, as I begin screen sharing, I will tell you that we'll begin with a short introduction on blockchain technology. And I apologize in advance to all of you. I'm sure you've heard 10 different definitions, or at least a single definition 10 times on what blockchains actually are. But just so that everyone is on the same page, we're gonna begin with a short 2-minute presentation on what blockchains actually do, and then move on and talk a bit about smart contracts and their technology, at least from a technical side, because I am as a programmer. I was initially going to talk to you about both the technicalities of smart contracts and how they're used in European and global businesses to generate value. However, I'm going to leave that to the experts. As you see, we've assembled an extremely interesting panel of experts here. And we have here both people that come both from the business side of things and the legislation side of things. So I'm going to leave that to the experts, although I'm still going to take part in the final discussion. Hopefully, can someone confirm that you're seeing everything just fine?
Yes, please continue. Mm-hmm.
Sure. Let me also full screen this. Right, is everything okay still? Right, okay, so to begin, as I told you, we're gonna start with a very short introduction to blockchain tech. Well, the concept of electronic cash systems has been discussed in computer science since the 1990s. It's not a new concept. Today, up to a point, it has been realized, but it is only still a continuation or a digitization of our existing bank system. Banks do still remain the sole handler of data and data transactions, of data and its transactions. Our banking still requires that we trust a centralized authority. Well, blockchains seek to improve cost efficiency and durability of the system by removing intermediaries in transaction systems. So looking at a simple example, say I want to buy something from you. Let's say I, as Dimitrios, want to buy something from Corina, say a phone. So you come to my shop, or Corina comes to my shop, scans her card, and what happens is that through the digital system of the bank, of the digital transaction system of the bank, we ask, or I ask, the bank and its ledger. I ask the bank to check up on Corina's financial records and answer me if she's good for the money. If she is, she just jots down a transfer from her account to my account. I give her my phone, and then the bank keeps a small amount as a transaction fee for its trouble. So what now if we wanted to use a more optimal system? Well, without having to ask the bank for help, well, who would we ask? I mean, Corina wouldn't like to ask me if I'm good for the money, because I am incentivized to lie about my own financial records. And in fact, Corina wouldn't trust the word of any single entity. Well, what if we could ask everybody, though? Well, on a blockchain, every single user participating on the blockchain network holds a copy of the entire ledger of every transaction having taken place on that blockchain. When you ask the network, they all check their individual records on their individual ledgers. They find my balance or they find Corina's balance, and they tell you if I'm good for the money in a process called the network reaching consensus, which you've heard about a lot. So, and a good question here would be, can someone forge his own copy of the ledger to maybe add a few zeros to my account or some of my friends' accounts? Well, yes, I can, of course, but the network now rejects me because my copy of the ledger does not match with everyone else on the network. So a blockchain is a decentralized network of shared records, as we said, constantly reaching consensus on its users, allowing them to transact on it. That's the basis, the simplistic basis of a blockchain network. Now, very short introduction, moving on to smart contracts. We have this naturally digital transaction system of a blockchain, which allows users to transact on it. What if we begin automating things a little bit? Well, if you dislike the term smart contracts, I'll have you know that even the creator of smart contracts, or at least the first implementer of smart contracts, also hates the term. And he has second thoughts about the term that was initially given to the concept by him, because he thinks it makes people think of something else entirely. Well, a smart contract, in its basis, is a self-contained set of rules that lives on the blockchain and is built to govern a mutual exchange of assets. You might have seen definitions of a smart contract being an autonomous daemon, or a persistent script, or an automatic or a trustless enforcer. Well, the truth is that a smart contract is a bunch of code programmed by a human and then embedded, deployed on the blockchain, that only obeys its own internal rules. And it automatically executes the terms of a transaction, the contract clauses of a transaction, the ifs, when some predefined conditions are met. And all that without requiring a trusted third party. To continue this, let's walk through this simple chart, or at least let's walk through this together. Using a smart contract to transact between two parties, say Alice and Bob, the first two parties say they want to perform an exchange of a purchase, of a house. So on the initial stage of this process, we have Alice and Bob. Alice wants the house and has the money. Bob wants the money and has the house. So these two parties that they want to transact together, they come together, and together they write a smart contract that will, in its clauses, will be built to govern that exchange, that specific exchange that they want to do, these two parties. It is a very specialized tool, right? So they create it, they write it together, and of course it's inactive and empty. On the second step, after creation, we move on to deployment. We actually take the smart contract, any of the two parties, and they upload it on the blockchain. The blockchain now lives autonomously on the blockchain, belongs to no one, but it's still empty. So what happens now? Alice and Bob, they individually send their assets to the contract, one by one. Alice here, sorry for the chart, denoted by the $sign, sends the money to the contract, and then Bob sends the digital certification of ownership for the apartment, for example, and they both send it to the smart contract, not to each other. Now, on the completion step of the process, the smart contract actually checks its own internal clauses, its internal code and conditions, and if it has the money and also has the digital certification of the apartment, it just performs the switch on the blockchain in a decentralized way. And at no point, you'll have noticed, at no point of this transaction do we have Alice or Bob having both the assets in their ownership. So no fraud can take place, right? Moving on to some questions about the previous process. So you might ask yourself, who owns a smart contract? Well, by answering this exact question, we also answer the question of why use a smart contract. Well, smart contracts don't belong to anyone, not even the programmer who built them. Truth is, they belong to the network, to the peers, to the community of the blockchain, and the autonomy and decentralization achieved through this lack of individual ownership of the smart contract enables them to be trustless, to be able to operate without requiring trust, and thus requiring no trusted third parties or middlemen intermediaries. No trust required between Alice and Bob or towards anyone else on the network, for that matter, means that a smart contract will deterministically execute its clauses, which is an actual big thing in computer science, determinism, always reaching the same result, no matter how many times you actually run an experiment or a process. A few questions on where is a smart contract actually executed? Well, a smart contract belongs to the blockchain, so it's also executed on it, on a part of the blockchain or every node on the blockchain named a virtual machine, called the virtual machine. Smart contract transactions are executed and checked on multiple nodes, multiple computers, different computers on the network. And the results of this execution, called an output, will have to match with the results and the output of every other execution result on the network, which is also part of the blockchain's consensus reaching mechanism, also in smart contracts. Although this seems a bit wasteful, it ensures safety and redundancy, a very big thing. No single actor in this whole process is ever fully responsible for the execution of a smart contract, therefore eliminating the possibility of fraud completely. However, of course not. Smart contracts, much like any other distributed system in computer science, will have problems that are introduced while some other problems are fixed. So it's not a panacea. We'll talk more about this in a few. To offer a quick look before moving on to the next speakers, this is an actual smart contract, just a very dumb contract, a very dumb example of a smart contract written in pseudocode. For example, I told you they are human readable scripts. I mean, scripts written by humans. This is a smart contract that does nothing else other than receiving money, recording who and how much actually was sent to it, and then just returns a message to the sender saying, thank you, I'm keeping this. So still a very valid smart contract, but a very simple example, just so you know what a smart contract actually is. The first part is the human readable form. It's how programmers actually write it, or at least in pseudocode. And again, of course, after it gets deployed on the blockchain, it needs to be in a form that the blockchain actually understands. This is the bytecode of the smart contract. This is exactly the same thing, just expressed in different languages. And the third thing is a bit of a middle ground. It's the machine code generated by the bytecode. All these three boxes are the same smart contracts, but the first one is built to be understood by humans, and the second form is built to be understood by the blockchain, and the third one also. Just so we have everything out of our mind. And then in the process of deploying the smart contract on the blockchain, of course, smart contracts operate out of an address on the blockchain. So we assign an address to our new contract through the process of deployment. We load up a new blockchain transaction, much like a transaction that you do to transfer money to someone else. We load up a transaction with our smart contracts code called the deployment transaction. We pay the deployment gas cost, and off it goes. We send it to the network. Our smart contract, if the transaction succeeds, now lives autonomously on the blockchain and is publicly available for anyone to use. Anyone else other than us, why would they want to? Well, in the case of public blockchains, we also have the all-encompassing transparency. We're also going to be talking about this in this open day. Some useful terminology that I'm going to really plunge through here, just so I keep it short on time. Some useful terminology, especially in this talk. Addresses, of course, are the basic representation of an actor, a user, or an autonomous agent on the blockchain. Addresses are everything on the blockchain. This is you. This address might be you. This is my Ethereum address, or this might be a smart contract. And signatures are also used in the same context that you already know in blockchains, only a little bit different here in smart contracts and smart contract automated systems. Signatures are used for access control. Your automated system, because it's designed by you, you want it to do specific things because only after specific users ask it to. So to offer a quick example on signature access control here, a smart contract which is facilitating a loan might require the release collateral function, which releases the collateral of the loan, to be called only by the address which is specified by the banker, as the banker. So only after receiving a signature from the banker can we execute the function called release collateral, for example. And the final terminology that we might be using here is that cryptographic proof in smart contract systems of a smart contract transaction, cryptographic proof, is the undeniable and accurate proof that a contract did something on the blockchain. It is used in the same way as normal cryptographic proof of transactions between users on blockchains. As we said, smart contracts, although autonomous, they act on the same data and they act using the same ways that humans do. So a smart contract transaction confirmed on the blockchain contains future-resistant details about what it did, how it did it, and what rules it followed to reach that decision, and what its internal state, of course, looked like at the time of execution, the storage space it has inside. Looking up a contract transaction hash on the blockchain will yield all of that above information, both now and what we say computationally forever. The information is going to remain there transparent forever, for as long as the blockchain lives. This brings us to a sort of data permanence in smart contracts. It's one of the biggest double-edged swords in public blockchains like Ethereum, for example, or Binance Smart Chain that you might have heard of recently. Data is, of course, stored permanently. This is the architecture of the blockchain. It will be there, the data, as an immutable part of the blockchain structure, never to be erased. Indeed, blockchains are the closest humanity has ever got to data permanence. And this permanence carries with it the weight of responsibility, of responsible use here, by the programmer, but also its users. An example of data permanence, which is a sort of humorous example of that, is the Bitcoin pizza transaction. I'm sure a lot of you have heard about it. On the 22nd of May, I think, of May on 2010, a young programmer, Laszlo Haniec, bought 2 large pizzas for 10,000 Bitcoin, which then was around $41, pretty expensive pizza. It does get more expensive because today's value of that Bitcoin is around €500 million, so 490 million euros. And of course, the record of his transaction is still there for everyone to see. And in his honor, or in his mourning, as we say, Bitcoin users celebrate the 22nd of May as Bitcoin Pizza Day. We all order pizzas and laugh at Laszlo for having spent 10,000 Bitcoin on 2 pizzas on 2010. Now, before actually moving on to the next presentation, Corina, I have another 5 minutes here and I'll be finished. A big thing in smart contracts and in blockchain systems in general is to understand trust. Trust has historically been a very integral part of contracts between humans. In fact, defining subsets of trust in good faith or in bad faith have been part of European law for decades, at least German law. What happens when the 2 sides of the contract have mutually exclusive gains, or how can trust be enforced in a contractual deal, or what happens when trust breaks? Smart contracts present a new way of dealing with trust. We don't need it in the first place. So the 2 sides can fully distrust each other for all we care. Smart contracts enable them to transact with each other, and trust is not taken into account. Trust, of course, has been traditionally been enforced in the form of an intermediary. So it is provided by a trusted third party, be it a lawyer, a legal firm, a bank, government. These are providers of trust. And in this ongoing effort for digital optimization, smart contracts need to remove all third parties and get as close as they can to the absolute minimum number of factors required in a 2-way deal. What's that number? 2 people. We need to get as close as we get to the minimum number required in a transaction, the 2 people. Smart contracts are designed, of course, to trust only themselves. And no matter who built them, no matter who is their own programmer and who deployed them on the blockchain, contracts follow only their internal code. And enabled by the blockchain's, of course, cryptographically secure and shared nature, a smart contract deployed on the blockchain can remain autonomous, and its law is only its own internal code, as we say. It only has one law, and that's its internal rules, its internal code. Of course, this will make apparent to you the obsolescence of intermediaries. It is apparent that a system that cannot and has no reason to move astray from its pre-designed behavior has no need for trust providing third parties, intermediaries. This determinism in smart contract execution is one of its major value bringers, and self-enforced trust needs to be complemented, of course, by complete transparency. Both actors, both users of a smart contract, need to be able to fully access and read a smart contract before actually executing it, before using it, to see what it will do once it gets executed. So, of course, as is the case in traditional legal contracts, why would someone sign a contract that they cannot read? Same thing here. And in the end, it is useful to think smart contracts as the building blocks of the digital economy. If smart contracts are trustless, and if they are deterministic in how they execute, always the same result given the same initial conditions, and if they leave behind them immutable cryptographic proof about every action they have ever taken, we can consider a number of modular smart contracts, purpose-specific smart contracts, small ones built for specific purposes, working together and using each other and taking input from outside users as the basis of an automated and self-sustaining and also circular digital economic system. This concept has been described as digital anarchy, and has been an internet endgame strategy since the birth of Web 1.0. We're talking about 1994 here, almost 30 years ago, that computer scientists and the people of the first web, the Web 1.0, have been trying to get this digital anarchy into the game, into place. And finishing up here with some good practices here. I'll just skip to the final slide after this. We need to keep in mind, of course, that a smart contract should not be treated like a traditional computer program, right? They have very specific change, they follow a different mentality, so much so that a mental shift is required when transitioning from using classical systems to peer-to-peer systems. And even more so when we're talking about smart contracts, which in themselves actually are very novel peer-to-peer systems. So a mental shift is required. What do we mean by that? Is that we need to ask ourselves if smart contracts are a panacea, especially coming from a technical background. Smart contracts are specialized tools which are designed and built with a specific purpose in mind, which is to regulate and to automate transactions. To that end, smart contracts have very specific uses and can deliver the most added value in any system under very discretely specified scenarios. As a Portuguese colleague of mine used to say, smart contracts cannot do everything, but what they can do, they do so fantastically well. Maximum added value, of course, and Adriana is going to talk more about this, I'm sure, can usually be derived through synpraxis, right? Through synergy. The interoperability of smart contracts with other traditional computer systems to support them. This brings out the maximum value. Again, we urge you, as part of the lesson, of course, to avoid blockchain everything mentalities, which are very catastrophic. And you see these mentalities being pushed, especially in business conferences or technical conferences related to smart contracts. Smart contracts are tools, and a tool cannot be used for everything. We urge you to avoid blockchain everything mentalities, and to offer a last example here. A library, like a library of books stored on the blockchain, is probably a very silly idea, right? It will not work well. But maybe a traditional digital database of the books with an accompanying smart contract system to handle the copyright, right? To accompany that system. Maybe this hybrid system or a smart contract system to do the renting on, or to do the sales or the attributions on, associated with and connected with a traditional digital system to actually hold the books. Maybe this whole system, maybe this hybrid architecture is a better example of actually utilizing a smart contract. So before finishing up this very pushy presentation, a quick heads up, all course material and teaching material from DLT for All is openly and freely available at the following site, dltforall.eu.
Sorry, Dimitri, and the class is also in the link that Sula has uploaded in the MOOC platform. We have the link in the chat. You can see everyone. If you are finished, we have already some questions. Of course, anybody of our panelists can answer, or you. The first I see is from Foodtruck AG. Would it be possible to give a proper example, please, like a rental contract between landlord and tenant going through it step by step?
Sure, and I'll be happy to do that after the rest of the panelists have finished. I have multiple examples to offer, and we can go through one simple one step by step, so we can actually look at the process and the code and the methods. Thank you very much for that question. I'll be happy to oblige you.
Would our panelists now can, Dimitri, we have met you. You have given a great presentation. Thank you. Dr. Haris Savidis, would you like to say a few words regarding your expertise?
Hi, Corina. Hi, everyone, and thank you very much for inviting me here. Perhaps the most difficult part when it comes to smart contracts is to ask from a lawyer to comment on this concept, because it involves the work contract, but it is rather hard to understand from a pure legal perspective where the contract is. And on the other hand, when you say smart contract, I'm sure you all understand that we don't feel very comfortable, because this is not drafted by lawyers. So if somebody else drafts a smart contract, then you immediately make the connection about the traditional piece of work from lawyers. Okay, this is a joke, but it is true that as Dimitris explained very well before, basically here we have a number of predetermined rules and promises that basically they take place on an automatic way. So, and the most important thing to note here is that this exercise is not something that is met only in conditions of a pure contractual relationship. In other words, at least from the common law perspective, in order to have a contract, we need to have an offer, acceptance, and consideration. So those are three core elements in order to have a contract. But in the area of smart contracts, this is something much wider. It's not restricted only in this contractual relationship involving consideration between the parties. So it is something that pretty much should be there in any blockchain type of transactions. And when I say transaction, I don't mean, of course, monetary transactions only. So any activity on blockchain requires a smart contract in place. Therefore, again, from my point of view and from a legal point of view, definitely smart contracts is something which is very challenging for us, in the sense that we used to connect this with services and transactions that pretty much require the participation of not just of the two parties that they have this contractual relationship, but also additional parties. And I'm speaking about middlemen, intermediaries, people that they need to confirm that money have been received before they giving out to the other party. Again, when something goes wrong and you need to decide, for instance, about the withdrawal from a contractual relationship or even the compensation. All this, instead of placing them under the scrutiny of a third party, basically in an automated way, they are regulated by default, let's say, in the smart contract. So from that perspective, it is very challenging because it helps to skip a lot of middle stages in the transactions. On the other hand, definitely it is not something that at the moment can be easily substitute all type of contracts that we have in place. We understand that there are contracts that either because of their complexity or because of issues that are very, very important, especially when it comes to liability and jurisdictions, they have to be, they have to follow the traditional route, at least until technology itself find more and perhaps better solutions from what we have at the moment. Because it is one thing to say where actually the smart contract is executed. Dimitris explained before a number of, I understand that these are a number of opinions, or let's say also depending on the case, we can say that it is pretty much everywhere, or in the computer of a certain of the programmer, or I don't know. It depends on the opinion that you follow. But this is not enough from a legal point of view, because where the contract is drafted and is executed is usually a very key element of the jurisdiction, that if something goes wrong and you end up in the court, who is going to decide about this case? And usually, not usually, but always, everything has a starting point. So again, it is not enough to say that the smart contract does not belong even to the programmer, because somebody, based on some conditions and some prerequisites, he made the smart contract. And therefore, if we end up again having any kind of deficiencies or any problems, or something comes out as a point of argument between the parties, we need to decide who is liable for this smart contract, unless, of course, again, we find solutions to approach these and to address these legal questions in a uniform way, which is again a bit of challenging, because don't expect all jurisdictions across the world to follow common standards on these issues. So overall, my point is that definitely we are experiencing something which is very, very disruptive in the legal sector as well. It's not just the name of contract, but it's the whole concept of them. But at the same time, we need to bear in mind that we have a long way to go, because there are still many and significant things to be addressed and discussed and find solutions in order to find the proper way, and in order to find a way to fit smart contracts in the daily legal practice.
Thank you very much. Adrian, I know that your time is limited. Would you like also to share a few things about your line of work and regarding blockchain?
Yeah, hi everybody from me. Thanks for having me very much.
Thank you
to the project and Corina, Dimitri, Shula, everybody who's been involved. Well, my perspective comes more from working with startups. I do not work necessarily with blockchain startups. Our company is a boutique venture studio. We're located here in the Balkans, and we work with both angel investors and startups. So we're very plugged into all different kinds of technology and so forth. And just a sort of I don't know if I should say a spoiler or a disclaimer here. I am very interested in technology and I work with it every day and love it. But at the same time, I also sort of, my own character is very much of an analog person. So I have kind of a love-hate relationship with technologies like blockchain. And that has to do with, I think the fact that, you know, blockchain, like any other technology, is only as good as its application and as the result of that application. And so, you know, there are, I think, since we're speaking about blockchain, specifically smart contracts, there are many ways that that DLT can enable transactions to happen much more quickly and much more economically, which is and can cut out a lot of corruption in some ways. And there've been all sorts of interesting examples in developing nations where blockchain is really revolutionizing agriculture, where it's revolutionizing the relationship between producers and buyers and so forth, and especially for consumers. On the other hand, you know, I definitely, and obviously I'm not a lawyer, so this is not my expertise, but I definitely agree with what Heidi was saying just now. There are many complexities in legal contracts and other kinds of contracts that are potentially very costly and disruptive if they're not gotten right. So an interesting or a good example would be right now we're one of our startups is negotiating for an investment, and the terms of that investment, once the contract is written, need to be done very specifically with regard to their particular situation and all the discussions that have taken place. And so the particularities of that contract need to be done by a very experienced lawyer who understands not just the transaction, the specifics of the transaction, but also all of the other issues that are surrounding it in the regulatory situation, depending on which country they're in. You know, what are the regulations regarding the shareholders, the structure of the company, what is the regulations regarding future investments and so forth. And the rule typically is that a tiny mistake can end up costing you more than the actual investment did down the line. If it's not done by an experienced, and there's a lot of in early stage investment with startups, there are a lot of contracts that are automated, and the startups like them, early stage investors like them because they're much cheaper to do and they're very simple. But when you get into larger sizes of investments, and those are something that could actually be very easily, I think, applied using blockchain. Or sorry, using DLT, and smart contracts between angel investors and startups. They're easily executed. The terms are fairly straightforward, and so it's not such a problematic area. But once you start to get into higher amounts of investment, if the structure of the agreement is not recorded in exactly the right way, then it can pose major challenges later on down the road. And so I think we need to differentiate between a transaction where the contract is recording the transaction of, let's say, goods or services, right? I'm selling my, my lettuce to the distributor and we're using it, or to the supermarket, and we're using a smart contract to execute it instead of going through the distributor where he takes a cut, right? Or I'm renting my apartment, which is a great example. That those are all very standardized procedures, and they can easily be transformed in a very positive way. But when you get into complexities that have a great deal of other agents involved, other than just the parties, or can be impacted by that, that's when I think it becomes a little bit problematic right now, at the stage that things are now. And that's another issue, is that I feel like blockchain in general, and I want to just iterate what Dimitri said earlier towards the end, which is we should really avoid the blockchain for all mentality. I think blockchain has sort of become somewhat of a very kind of cool technology, and there's a lot of desire to jump on the blockchain bandwagon for the sake of being saying, yes, I'm doing this with blockchain. And it needs to be used because blockchain is the right tool for the job, as Dimitri said, rather than as because it's a cool thing. One of our one of the startups that I was working with a couple of weeks ago was describing his project to me, and he said, we were doing this, we're doing that, and in the end, I'm going to do an ICO. And I said, oh, okay. And why? And his startup had to do with CO2 emissions and trying to reduce CO2 emissions. And I said, why are you planning to do an ICO? And he said, well, because I just think it'd be a really cool exit and people will be really attracted to my ICO. And I said, well, there's a problem there, because first of all, if you're dealing with CO2 emissions and you're using blockchain, you've got energy usage problems right there. So it's a little bit of a disconnect. Anyway, my point is that I feel like that blockchain is an incredible, and DLT, as they're applied in smart contracts, have a great opportunity, present a great opportunity to make things better and cheaper and faster, for sure, as long as they're applied in the right circumstances right now. And that will obviously grow and change as the technology matures and as people are more able to use it as well, because that's another issue too, is, as several of the commenters and as Dimitris addressed and Hari says, if people don't understand the terms of the contract, then it's actually can be disruptive in a bad way as well. So I don't know that we've kind of taken the discussion off in a direction there, Corina, and away from some of your questions, but it was very, very interesting to hear Hari's opinion and Dimitri's talk. So.
Of course, yeah. Thank you so much. We do have an interesting question in the chat from Jamie Brown. Do we not need a third party to also check the contract programming language and put the contract into layman terms for the actors, say a solicitor? I would find it hard to trust the contract if the other party had created, if the language it was written in was not totally clear. So for our panelists here.
If you will allow me to take that, Mr. Brown says something very, very correct or very valid, if I can say so myself. Something that is not the case in traditional contracts, in the legal, of the legal kind. There is at least an understanding, or at least we get a very specific baseline, since all lawyers are very classically educated. That the basic human language that the contract is written in is at least up to a degree very understandable, or at least can be sufficiently understandable by a different lawyer. And so a second lawyer can always look at a contract created by another lawyer or created by another group of people, and chances are he will understand what it says, right? The thing about smart contracts is that, yes, you do not need a third party to check the contract code, right, the internal workings of the smart contract, but the programming style or the language style of a program of two different programmers can vary wildly, and things can get messy very fast. And this is also ignoring the fact or not taking the fact into consideration that someone might be obfuscating their own code on purpose just so that he can hide little details that he may not want to be found later on. And we have multiple examples of that. Creators of smart contracts actually scamming their clients or their investors by intentionally writing bad code and very hard to read code so that people do not understand what's going on, and people do not find that vulnerability that they will at a later date exploit themselves to scam their client, but also deny the reason to do that. So it is valid. Yes, it is transparent, but nobody is actually guaranteeing you that you'll be able to read it well. So that's why, of course, as programmers on smart contracts, we follow specific design patterns, and we follow styling guides so that code remains understandable, at least. A good rule of thumb here, a good strategy here, is that if you do not easily understand the code, or if the code is not sufficiently commented, do not use the smart contract. And that's the basis of it. I'm sorry for that.
Sula has a great question. Does this mean that law study should be modified or a new curriculum is required? Maybe for Mr. Savvidis, for Dr. Savvidis here.
Yeah. Well, first of all, don't expect lawyers to be willing to become programmers or be capable to become programmers. And I don't believe that the other way around also applies. So either we like it or not, our studies will not change to the extent that saying, for instance, that a lawyer can also do a bit of coding and write a smart contract, and instead of writing on paper, just simply create a smart contract and that's it. No, I don't see this as a possibility. What I see as a possibility, and I don't think that this will be in the very near future, but at some stage, yes, perhaps for more mainstream and repeating contracts, easy transactions without complexities, yes, okay, it could be an option. But don't expect, for instance, a share purchase agreements for the sale of a company to be on blockchain or a smart contract where you have numerous of points to be addressed properly and reviewed. And definitely even the man hours that you will need in order to review the contract or even to create the contract, having a programmer and a lawyer working next to each other, but also have a third party, as mentioned before, to do a bit of an audit review of the contract. It doesn't make sense from business perspective or even for financial perspective. I mean, to cover and to pay all this money just to get a contract. All right. So again, as I said before, maybe after a few years, when for daily transactions that they do not involve complexities, yes, that could be an option, but nothing more than that as a substitution of the traditional legal work in the field of contracts. I think we have another question.
Mm-hmm. Yes, if you may.
From a colleague.
Yeah, we have a lot of questions.
Yeah, I see the point from my colleague here. I mean, with 35 years experience, and yeah, this is indeed what I'm trying to say, that especially the last decade, and I'm talking as a business lawyer as well, especially in the last decade, having to deal with all these compliance requirements, so many regulations, so many new things every day, a lot of things to be addressed and often to be discussed between lawyers from different jurisdictions. So our daily practice has become itself so complicated that it requires time to get this regulatory alignment between ourselves. First, that's the first step. And until we get this regulatory alignment, something change. So again, we have to do the same exercise. So I don't believe that it is easy to get away from all these things just by creating a code or just switching to a smart contract.
Great, thank you. We have a question in the QA section. I hear a lot of disruption in banking and financial sector. What are the key changes expected, and what do you expect the role of bankers would be? Who would like to answer?
I can say just a few things, and my colleagues can add on this. First of all, it is interesting that the first red flags, in most of the cases, closed doors, come from the banking sector. When it comes to digital currencies and in some cases even to new, even to the technology to some extent. But at the same time, it is true that fintech has attracted a lot of attention the last few years, and for reasons that have to do with most cost-efficient policies from the financial institutions, less staff and more productivity. These kind of things have shown that definitely products that can satisfy these needs have a very key role to play in the financial, in the banking sector more specifically. The question, however, is that speaking about smart contracts, definitely we need to be very, very careful, because it is not very, it is not simple or very efficient always to switch to from traditional banking products and services to something that is simply done without the interaction between people, because just imagine having an issue with your bank account and you want to resolve this issue, and you just speak to a machine and try to resolve this issue, and there is nobody on the other line. It's like flying with an airplane, and at some point they tell you that the pilot is not there, although it is a very high-tech airplane. I mean, okay, I think that it is very similar to a situation like this.
Yeah. I have a question. Do political factors play a role in the future of blockchain in general, and should governments intervene, and how? Maybe for Adrian or Mr. Savidis? Should governments have a role in the future of?
Definitely. I mean, it's the number one role to play, because without proper legislation, without a regulatory framework regulating not just the way that these things operate, but at the same time the acceptance of this technology in the public sector or even in the courts, it still remains a private issue, meaning that if both parties agree that we are satisfied with having our contractual relationship placed under a smart contract, then it's fine. But if there is no such agreement, and if there is no regulatory framework setting up the standards and the criteria and the conditions when these apply, I'm afraid that there is no future here. I'll give you an example in order to make myself more clear. A couple of years ago, we decided in our law firm to have share certificates on blockchain, on Ethereum blockchain. So in simple words, instead of printing out, the paper share certificate, we also gave the option to our clients, when it comes to incorporation, to issue their share certificates in PDF that are on Ethereum blockchain. And in this way, we simply email the PDF to the shareholders saying that, okay, this is a proof that you are the shareholder, and you know how it goes after that. You can share, you can share this certificate with anybody. You can discuss the sale of your shares, the pledge of your shares. You can do pretty much whatever you want by simply presenting this PDF to anyone. And here is the website that someone can verify the authenticity of this certificate in a couple of seconds. Okay, this is something that it works. We have it there. We encourage our clients to use it. But I have to admit that at this stage, without proper legislation to accept blockchain share certificates as valid certificates, it remains as a training session for our clients rather than having a practical significance, unless, of course, the other party accepts this the technology as a technology that indeed helps and allows the validation of the document in seconds. So we understand that yes, government, legislators, regulators is a pillar in the whole process.
Thank you for your answer. We have a lot of questions.
Corina, if I can add to the answer of Mr. Harris, the thing about banking, right, and to continue on that answer about banking and how it changes through decentralized means, especially smart contracts and blockchain, I guess. The thing is, it is a very disruptive technology, especially on that field, because truth be told, the first use case of blockchain tech and smart contracts was, of course, transfers of money. The thing is that I wouldn't know so much about commons law, but tax law has been trying to keep up with this whole situation for the past decade, for sure. The thing is, and as Mr. Supra, and I hope I pronounced this correctly, said, where will bankers be in a few years? The truth is, decentralized finance, the field of DeFi, has been outpacing traditional banking for the past year. And this is not something that's an opinion. This is an absolute fact. I mean, most decentralized exchanges right now, which of course act as banks, offer compound yields in the order of 50 and 60% yearly, which is far above any traditional bank can offer. What happens here is that as tax law is attempting to keep up with the latest step in the technology, with the latest the latest frontier in this technology, is that they're actually trying to catch you, if you will allow me the term, whenever you actually try to get back to the traditional system that truth be told, governs your everyday life. So it is only a question of trying to find the bottleneck in how these two systems connect with each other. So you can make as much money as you can as you want in a decentralized financial system, in a decentralized bank, or on a DEX, a decentralized exchange. But the moment that you return to the euro system or the dollar system or whatever other traditional currency you have in your country, it is a taxable event. So it is not a matter of the law being too far back, left behind. Of course not. It's only a matter of how this law manages to find the bottlenecks and grab you and hold you accountable during these bottlenecks. And what are these bottlenecks? These moments, these taxable events where you get from the decentralized space back to the real space, back to traditional space. And so far, this is how it happens. I mean, every sale of cryptocurrency, once converted to euros, is a taxable event. And it's up to you to prove it. So this is the situation right now. But truth is that decentralized finance has been outpacing traditional banking for the past year, for sure. I don't want to say 2 years, but for sure the last year.
Okay, thank you. So continuing with Mr. Rodi Stegeman regarding gas cost. Did you see that question? It
yes,
says gas cost.
It's actually two questions connected together. I can quickly address those. Gas costs in blockchains.
Sorry, Dimitri, can we just address them so for everyone to hear? Let me just say the question.
Sure, yeah.
Does the cost of gas not increase with the number of completed transactions? And at what point does the cost become so great that the smart contract loses its attraction?
Right, and the second question is that is it not possible to ruin a blockchain by simply filling it up with empty contracts? So these two questions are connected. For everyone that might not be aware, gas costs are a mechanism in blockchains that require a minimum amount of money, something very minuscule, for a transaction to go through. It's called a transaction fee, and it's usually either burned or redistributed to the people doing the mining on a blockchain. So every transaction takes a little bit of money just to go through. This discourages us from actually spamming transactions and destroying a network this way. So it acts as a fail-safe, because one transaction costs nearly nothing in most blockchains, while spamming 1 million or 1 billion transactions quickly comes up to a very hefty sum that most people cannot pay. The thing is, with Rodi's question, that gas costs, say on the Ethereum blockchain, recently became absolutely huge, and also on the Bitcoin blockchain. So for a transfer of $50 or 50 euros on the Bitcoin blockchain, right now you need $27 as a $26 for a fee, for a transaction fee, which is insane, right? So on Ethereum, it's something like 190 gigaway of Ethereum that comes up to like 17 or 18 bucks. Am I correct? If someone wants to correct me on that. So the transaction fees right now are insane. I do want to tell you, though, that blockchains are very much alive systems in the sense that if transaction costs and gas costs get too much, there are development teams responsible for the whole protocol that do steps and take steps to actually nullify that, or at least minimize that, and change the network to a different point or direction. I'm sorry. The thing is, for Ethereum, for example, we have EIP 1559 planned for I think July 2021, which is going to cut and burn most of the gas costs on the network. So a network is congested. It takes up a lot of money to actually move money. Gas costs are through the roof. This is a whole different discussion altogether. And to fix that, there are improvement proposals on Ethereum as a very much alive system that will attempt to solve these problems. Blockchains, and even the Bitcoin blockchain, which is the oldest out there, they are not static systems. There are programmers behind them who push for changes and push for patches, and the procedures change all the time. So it is a human-governed system after all. And of course, for the second question, I'm sorry, Corina, you cannot spam or you cannot disable a blockchain by filling it up with empty contracts. Basically, to not get too technical, if a contract is exactly the same as another contract on the blockchain, it doesn't get replaced. As I said on the start of the presentation, I would like you to think as a smart contract as a machine and not a legal contract, a legal paper contract. A smart contract on the blockchain is endlessly reusable. So if I make a smart contract to transfer an amount of money for someone else's house and say I'm trading with Corina, the same smart contract can be used by Corina and Mr. Savides. So a smart contract on the blockchain is reusable. And if it looks exactly the same, the blockchain just says, why would I need a new one? I already have it up there. So just use that.
Mm-hmm. Yeah.
Great, thank you. Can we open the mic for a question, Valentino?
I'll close mine.
Is that possible? Okay, we'll continue with a question I have as well written. Can we open for Mr. Theodoros Michalareas in order to speak because he has raised his hand? Thank you.
Hi guys.
Hello.
For putting this presentation and hearing so much about blockchain. I wanted to ask you if you feel the latest deployments of new features in the blockchain, like the Lightning Network, will make any difference in terms of the scalability of transactions, because I think that's one of the major issues with the blockchain system, the type of transaction throughputs they can support right now.
If you will allow me.
I would like to take it this, yes. Mm-hmm.
Absolutely, Mr. Theodoros. All these solutions, the Lightning Network, or I think it's called the Harmony Network on Ethereum. These are what we call layer 2 solutions. So it has become apparent that the layer 1 solution, the base solution of the Ethereum network or the Bitcoin network, they have become so viable that it is no longer viable to transact on them, or at least not transact cheaply on them. So as was initially designed, a problem or a need warrants a solution. So a problem pushes for a solution at this stage. So multiple layer 2 solutions are built on top of the previous network, right? Like the Lightning protocol or the Harmony protocol, which are built exactly to solve the problems that we face right now. The fact that Bitcoin and Ethereum are no longer scalable. I cannot predict the future, but it looks like Bitcoin will never be scalable again unless we use the Lightning Network or unless we use other layer 2 solutions. But it isn't something bad. I mean, building tools to work on top of tools. This is the basis. This is the basis of every science.
Okay, great. I'm not sure if we can talk, right? You can unmute your mic if you want to say anything more, Mr. Okay. Okay, we are okay. Will I continue with the written question we have? How could projects like Kleros Court, in case you have heard of it, not only make the usage of smart contracts more common, but also to some degree introduce decentralized courts?
Well, I'm aware of this. It's called Kleros Court, and this comes from the ancient Greek word kleros.
Oh, right. Okay, interesting.
It refers to the people. So it's a people's court, in other words. Basically, this is, if I'm correct, this goes back in 2017, and it was, if I'm correct, it was an ICO that basically advocates the usefulness and the necessity of having a sort of decentralized arbitration system where the users basically recognize and that for any disputes they have those should be referred and resolved by a decentralized arbitration body. When I first came across this, my instant reaction was, okay, if I was someone that experienced problems because of something went wrong with the machine, I wouldn't entrust my verdict on the machine either. So I would feel more comfortable if, at least at this stage, a different, a more traditional concept would follow. Anyway, this is my opinion, and definitely this is not a very, we cannot give a very simplistic answer on this question. On the other hand, of course, we need to say that when it comes to such core functions of a democracy, right? I mean, we have the three powers. I mean, the parliament, the government, and the courts. It's very hard to accept that this can go from one end to the other in terms of the way that they are delivered, because according to Kleros, we're talking about something that it's a substitute of the core systems, of the judicial systems that we know. Of course, if I remember well, it was in 2018 when I presented my results from a research I made on something similar about the legal sector, and I'm talking about how blockchain can be used in order to experience something like Uber for lawyers. So it's I named this as the Uberization of the legal sector, which basically, when it comes to not the judicial system, but the legal services, imagine that Dimitris, Corina, and all our friends here, we're sitting in our place, and we need to get access to some ordinary legal service, and we simply check out nearby lawyers. All right, it's the same concept. All right, but the difference here is that, okay, we all know how mobile technologies and how internet, okay, controls and is controlled at the same time by us. So imagine the scenario where you want to instantly to get quotations for a simple work from a number of lawyers from home, all right? And you simply call the job and you start receiving quotations. All right, so far so good. However, we do not know, first of all, if the cheapest one is the best for our job, or we need to go with someone who is more expensive, or even the most expensive one. And at the same time, we are not sure. I'm just giving the example that I am a lawyer for so many years, and nobody ever entered my office asking me if I have a certificate to be a lawyer, or even if I have a professional indemnity insurance. Nobody. And I'm thinking that the reason why I have not been asked is because they feel shy to ask me, all right, or because they believe that, you know, if that person is being trusted by a number of other people, all right, and he has a name, a good name, etc., he must be a lawyer. But nobody asked. So nobody knows at this time if I have a disciplinary offense, for instance, or I haven't renewed my indemnity insurance, or if I am capable of delivering this service, and what track records I have in producing this service in other cases. So because of transparency and because of trust and all these elements that the blockchain technology can offer, my suggestion was that we need to start thinking about it very seriously for two reasons. First, because of the benefits that the technology can give to us in order to overcome these problems I have just mentioned to you when it comes to the provision of legal services and the honesty and the transparency that needs to be in place every single time. And the second reason is because, believe it or not, in the USA, the last 5-6 years, the virtual law firms in the USA, the progress and the development of them is 400 times bigger, I repeat, 400 times bigger than the development of traditional big law firms across the States, which means that the trend in the market is that you don't see offices, you don't need to visit an office, you have these virtual places, you just you connect with your lawyer through internet, you are being redirected to a lawyer that is expert in this field, and everything is done in a remote way. So you understand that for these two reasons, the momentum is great to consider the legal service and the legal sector more broadly under these conditions. Not so sure about the judicial system, as I mentioned before, but at least the first one, yes, there is potential and scope.
Corina, if you will allow me to piggyback off Mr. Savvidis' question that he just answered, and to allow me to answer a previous question, one of the first questions that Mr. Futrak asked on the chat, to actually show an example of a smart contract. Why not attempt to showcase an example of a democratic process through blockchain? And I asked Mr. Harris to tell me in the end of these 2-minute presentations how many legislations I broke through. Because it is very usual between a programmer and a legal professional that the technicalities or at least the technical process breaks a lot of things that it shouldn't be touched. And I mean, and of course I'm not a professional in legal matters, so I usually do this with our own lawyers as well. So to offer a simple example and to showcase the capability of smart contracts for democracy, for digital democracy, I will now share my screen, and we will attempt to implement a simple democratic voting process that can be changed up and down to whatever voting takes place on a national scale or on a local scale. Let me also, sorry for this. So let's set the basis for a voting process, right? A simple democratic voting smart contract or a simple democratic voting process consists of the following criteria. This contract that we'll implement has candidates that will be gathering votes, right? So anyone on the blockchain, which means any address, can vote on a candidate, of course, through a function called cast vote. So every user can cast a vote, can use this function. Anyone on the blockchain can inquire about the votes that a candidate has received. So anyone can read how many votes a candidate has received using this function called total votes for. And all blockchain users can vote freely, and their vote transaction will be permanently and immutably stored on the blockchain forever as a pair of what address voted for what candidate. And this is forever and permanent and immutable. And also some helper functions will be implemented. I will ignore that because it's a short example. So so this is the outline of the process, right? A deployer address, in this case, whoever, let's say me, deploys the voting smart contract, and then voter 1, voter 2, and voter 3 can come along and vote on their candidates. This whole process means that every unique address can follow a function, can run the function cast vote with a name at the end, and the smart contract will go +1, +1, +1 on that specific candidate. At the end, you're going to have the results of a voting process. Now, a voter, of course, cannot vote if he doesn't wish to do so. He can just read the results, and he can call the function total votes for. So we see voter 3. And the smart contract will just return the number that this specific candidate has received. So to showcase the strength of all this of this use case, the smart contract that facilitates a democratic voter contract is this. It's 30 lines of code. And in these 30 lines of code, we have created such a transparent process and such an immutable process and such an unhackable process that has never been achieved in the last 50 years that computer science has existed. This is the strength of smart contracts in this case. Of course, this is very problematic because at the first stage, you actually need the government to actually issue unique addresses to its voter. But I think there's a sort of magic that in 30 lines of code, you can code a system more powerful that has ever existed on the traditional world of computing. So, of course, there's many mistakes here, and it's a very simplistic example in the sense that voter 1 or voter 2 can keep voting because the current code in 30 lines does not check if an address has voted before, but this can be easily fixed. And of course, you need a preparation stage where a government, for example, will send out addresses which are tied to a specific citizen that will be able to vote and take part in the process, maybe through TaxisNet or Aave or whatever national system is already in place. And of course, this uses no coins, this uses no Bitcoins or Ethereum or anything else. Indeed, a smart contract is designed to only selectively take advantage of the tools you have offered. I will not stay on this too much, but just to add on that question that the capability is immense, and the capability for automation is immense, and the capability in general for democracy itself as a field of study is terrible, and I mean it in the best possible sense. If I can stop sharing now.
Thank you, Dimitri. Mm-hmm. We have one last question in the Q&A section from Camille Patrick. Does blockchains present also new investment and financing opportunities in the short and long term, which move away from debt and equity, financing and investments? In the short term, does it provide alternatives to replace working capital and cash flow financing? For example, debt factoring, ad invoicing, or even overdraft facilities? That's a long question.
Question for Adrian. Unfortunately, this is not with us in this call anymore, but this was a fantastic question for Adrian.
Yes.
Unfortunately, I don't have much experience with the financial sector of blockchain in general. I do have some experience with DeFi, and I keep seeing new synthetic asset trading on decentralized exchanges and on blockchain. So that means that up to a point, there is sure to be some debt or capital trading happening right now on blockchain. I'm not so sure that there's any large-scale solutions yet. And there is a big issue about the legality of these enterprises, especially if they are fully decentralized. Who do you speak to when something goes wrong? That's a concern. But unfortunately, I don't know any more about this sector.
Yeah, just very briefly, a couple of points on this question, because I understand that we are also running out of time. But yeah, already we have I would say, significant disruption in the financial and investment sector because of blockchain technology. Okay, starting from what turned out to be not the proper way, but at least it was there, and I'm referring to ICOs. Yes, crowdfunding was number one reason for developing projects like ICOs, taking advantage, of course, of blockchain technology, all right? And again, and this used to be linked also with startup companies and the difficulties to access banks for loans or investment funds. So pretty much, you know the story about ICOs. But moving into more sophisticated structures, it is true that what we see happening nowadays with a massive trend in the field of asset tokenization, thanks to blockchain technology, it is something that, of course, is closely associated with the investment sector. We are talking about securitization of assets in a digital way, things that in the past, because of the technology, were not so much of an interest or even of concern or a challenge. Nowadays, people want to look at them and try to make most of it from these technologies. We also see the so-called NFTs becoming very popular, especially in the Asian markets, non-fungible tokens, where pretty much we're talking about tokenizing anything.
Unique assets. If
Anything that has a digital, ownership, but we refer that starting from a picture, a digital picture, a sound, a piece of art, that it is in a digital form, and you actually get ownership of this. All these are thanks to the technology, and all these belong to the broader area of investments, meaning that the question every time when it comes to these products is whether what you sell in the end of the day is a security or not. So that's a million question every time. And for most of the regulators across the world, the answer has been given, saying that everything is considered to be security, and it is a burden of proof on your side to prove that it's not. So it's not the other way around. So this is how the disruption works at the moment.
Great, thank you. We have to wrap it up. Thank you so much for all the questions and comments you made in the chat or in the Q&A section of the panel. I would like to conclude by informing that we have great material on the MOOC platform from DLT for All project. And also we have our curriculum in the website. You can see in the chat the links. And if you have any further question, please contact us. I would like to...
For Dimitris and pizza.
Yes, yes, exactly. To celebrate. Thank you so much, our panelists who gave us their expertise.
Thank you, Corina.
We have a question where we can attend the MOOC.
On the DLT for All platform, I think registrations will remain open until 2024. So it should
yes,
be
you can make the registration. The link is added from Sula here, so we can take that. So thanks again. Thank you, our panelists and everyone attending.
Thank you very much.
And if you have any further question, please contact us. Have a nice evening, everyone.
Thank you. Bye.
Thank you, everyone. And
Goodbye.
thanks for the questions.